Brian here again from quantlabs.net. I'm going to be breaking up this overview of the new, I don't know if call it new, but the Fastflow version 2 that's I was going to look at, but decided to see what's in it. First, I just want to show you how to get access to it. Come to the SourceForge, the Fastflow project code. SVN browse if you want to see some of the code online. If you want to download it, you'll need the SVN. Once you install your SVN, just type in that. That's why I like my Ubuntu. Nice and easy. Good luck with it in Windows. So let's jump into our Ubuntu Linux environment. So essentially what I've done is I've SVN'd the project into this folder here. Everything's still the same in the previous version of 1.1, but there are some differences both in the examples and the tests. I'll just show you right now. First of all, the one that really stands out is the speed denoiser. I'm going to leave that for a second video because that in itself is probably a good chunk of time talking about CUDA code, how it's used with the Fastflow. As well as, you know, where does it go from there with the multi-threading, as well as the GPU and CUDA sort of coding capabilities that I'm looking at. I've never seen this type of code before. I've heard about it, but I'm going to look at it and probably do a whole overview of it in another video. So regardless of that, I'm going to show you some other changes as well. If you come under the tests, come under the MC Fastflow and just come under tests here. You find various new, I think they're new, test examples. Remember, this is all done in C++. And there's some that stand out to me. Hopefully if you watch the other videos on Fastflow and what it is and what it can do. But there's some really good standout examples. I'm still, I mean, I understand how Fastflow works, but just trying to implement things like R calls into it and be able to optimize the R calling and the multi-threading capabilities within a C++ and a R environment. It's kind of strange, to be honest. I've seen examples with the OpenMP. This is something totally different. This Fastflow is a lot more advanced. So let me show you some of the examples here. So right now we've got the accelerator. Remember that accelerator is virtual, but now we have an option where not only is it virtual or through the software, but we can also do it through the code CUDA. Again, another video, another day. So you set up your workers, again the service method, which does all the work. You get your collector, and then you call your workers, set them all up, and I'm not sure if this one's got a farm in it. It's got the accelerator code in it. Very small, very tight code. There is the tutorial, but that looks like for version 1. So if you come under docs, you'll find the Fastflow tutorial that I went on about in the last video, which is very helpful for people getting into this stuff. So there's that code, and then let's move on to the really juicy stuff. Not only do you get the accelerator, but you also get the pipelining and the farm capabilities. So here you have a 3-stage. Stage 1, you build the farm, you get 3 stages which get run, and then the stage, and it comes back to the main flow. Pretty simple. But again, this is all done through a pipeline. Again, we set up different stages, all done in here. And this is where you put your logic that you want to split off into separate processes and put them in each unique set of workers. Again, the capabilities to set this stuff up is really, really basic, very fast. You just build your workers, add your stages to each worker, and you build a farm from it. Here's you build your pipeline, and then you run it, and should be the farm code in there to add it. You've probably seen it numerous times if you watched the other video. I'm not going to worry about it, but it's the same. Here we go. Here's the farm code, the pipeline code. This thing just blows my mind on how good it is and how tight it is. Again, this is all utilizing all available memory within your CPU. So let's go on to the next one. This example just shows a dot product of two arrays. It's pretty fast. So you set up a map function and a reducer. So guess what? You've now got the capabilities of classic Hadoop built into this platform as well, or into this library, which is kind of cool. I'll show you a better example of that. But those capabilities do exist within this library now, at least in version 2. So we should all be jumping for joy and sending these guys in Italy cases of whatever they drink for doing a fantastic job on this architecture. Just really, really powerful. So there's that. Let's give a very simple mapping capability. So again, we have a map functionality, create your workers, you have a partitioning. Now this is somewhat undocumented, I believe, so I have to kind of dig deep into that. So if anybody has any knowledge, let me know. I would appreciate it. But as people need to understand, this version 2 is probably still under development. I'm not sure if it's a stable release yet. But the coding shouldn't change too dramatically, but I still think it's good for demoing purposes of what's coming in this version 2 of Fastflow. It's quite good. So let me show you another example of mapping. Doesn't look like much difference, but I think it just uses the pipelining. Yeah, so big whoopee. But the map reduce is quite powerful. So get the mapper, the map function to reduce. It's called from the collector. And then remember there's the emitter and collector, set up the workers, set up our tasks, and then here's the map reduce. So pretty powerful stuff. Okay, let's go on to the next one. Now, we're getting into some more complicated stuff, the master worker. So it's no different than probably the OpenMPI that I've shown with the Beowulf cluster. So we set up our number of workers, and so we set up our classic worker here. We've got an emitter. We've got our number of workers. We set up a farm. We've got our workers again, so we have our master node here. Now we're going to run the what do you call it, the accelerator. Remember, this end of stream EOS is received. This is coming in from streaming. This is going to be good for from a trading perspective. This is good for, let's say, if you are listening to your ticks. I'm trying to figure out how to make use of it, but there's different ways about it. So nothing new here. Let's get on to the next one. Now, multi-input. This is kind of complicated from what I've seen. You know, pipeline, 3 workers, default emitter, I guess. no collector present. So all standard stuff. So you have two different types of workers here. I mean, I'm not even sure. Yeah, I'm sure you could do it within OpenMPI, but the coding and just the setting up of it was just pure complications versus just simple code like this and just calling it from elsewhere. It's pretty good. Nothing out of the ordinary here. Gonna let people figure all this out on their own. But I just want to show you the capabilities. Now this might have already existed, but the Fastflow is quite powerful where you can control the scheduling. So you can set your own scheduling policy within this library. And then you got the workers get set up. Then here's where you can override the load balancer. Okay, you can have your own custom code for that, which is quite powerful, as you can imagine. We have an emitter built. So there's some custom code here that you can enable, which is quite powerful. I'm not even sure if you can do that in OpenMPI, but either way, this is well architected from that point of view. Now, let's say we're going to send out. Now, it's going to test the difference between a standard pthread, I believe, and the one coming out of the Fastflow. Does some metrics and stuff like that, but not too concerned about that. Now this is another interesting test. I know this exists in the previous version. It's just a classic pipeline. The pipelining is a new concept that I've come across, and I've explained it in a previous video. But it's pretty powerful for the sort of stuff I want to do, is to be able to transmit probably thousands of ticks into some kind of process to get processed, and then have these workers set up internally within a memory available, and be able to do some funky stuff. But that's the testing code of this up and coming version 2 of Fastflow. Really impressive. So next video I'm going to show you this little project here under the examples, the speed denoiser with CUDA code. I'm going to check that out.